A warm welcome to the audience, and thank you very much for joining the webinar today, for signing up. My name is Christian, but I will introduce myself later on. And I was thinking about what to tell you in the beginning, because we are going live in a few minutes, I will tell you. And we will record our presentation today, which will be available on our webpage. We did already a few webinars last year in November and December. This will be available on our webpage as well. We had a lot of sign-ups, which we are very proud of. There are over 200 people from all over the world, from each continent actually. And I'm very proud to give you the presentation today. And yeah, we're thinking about what to tell you to get a little bit warm with each other. As everybody knows and see when you look outside the window, that we live in a very unusual time, and everybody has maybe a little bit more time to think about themselves. And I just wanted to say in the beginning that if we give a little bit more than we get, the life will be much brighter. We have 45 minutes today, and hopefully, yeah, you will find the presentation useful. So let's start my presentation. Let's go. Let's start recording. I'm talking about glass fiber reinforced polymer bridges. Most of the people say Gfrp, but there's also Cfrp, carbon fiber reinforced polymer. Many people say just Frp, but I think they just mean glass fiber reinforced polymer. I will switch between both Gfrp or Frp, but it's actually the same. I just give you an introduction on our agenda today. I give a little presentation about myself, about the company. It's very important from my side, from my view, to go through the basics first before we start talking about application areas, advantages, load application, environmental impacts. Very important to mention is the life cycle cost analysis. I get many questions about the design guidance because there is no Eurocode available on the market. I'm talking about the painting and anti-skid system. on FRP Profiles. And at the end, I will answer a few questions, maybe not all of them, but I try to answer all questions separately in an email, or just give me a call, and then we can go through more in detail. Yeah, my name is Christian Schulzer. I'm German. I'm working for a Danish company, Fiberline Composites and Fiberline Building Profiles. I work for Fiberline for more than 10 years, and I'm responsible for the sales and customer relationship. I'm married, have 2 kids, and I love playing tennis, and I like to go skiing. A brief presentation about our company. It's a family-owned company, founded by Henrik and Dorte Thorning in 1979. We are protruding glass and carbon fiber profiles. And Henrik Thorning, he perfected the protrusion process in the end of the 70s and the beginning of the 80s. We are 2 companies today. Fiberline Composites. We supply the wind energy by supplying glass fiber strengthening profiles and carbon strengthening profiles for wind blades, but also supplying tower internals like platform systems and railings. I'm working for Fiberline Building Profiles. We supply material to the building industry. We supply FRP from all over the world from Denmark. Now I'm talking about the basics to give you an introduction. In other webinars, we go much more in detail in the pultrusion process and talking more in detail about glass fiber packages and different resins and polyesters you can use to pultrude FRP profiles. But let's go through the basics. It's very important to mention that FRP is an elastic material. It's anisotropic, which means different mechanical properties in each direction. It's a very good weight strength ratio we have here. The E modulus is between 24,000 megapascal to 31,000 megapascal. The expansion coefficient is similar to steel. If we compare a steel with an FRP beam to get a better feeling for the material itself, if we put a uniform distribute on a certain span, then we need about the double of the structural height in FRP to get the same deflection. But in the same time, we're saving a quarter of its weight compared to a steel beam. The design is mainly based on the deflection criteria. Something I just wanted to tell you also, that you can cut the profiles with a diamond tip blade, and you can drill with a diamond tip driller. I'm talking now about the profile range we offer to build bridges. It's similar to steel shapes, square tube channels, angle profiles, C profiles, I-beams, and strips, for instance. The dimension of the profile has been optimized in conjunction with the fiber package. On our webpage, you can see the whole range of products, both stock items and non-stock items. We stock 6 and 12 meter length. You can download DVG files, load tables. We give you everything on our webpage. We do sell our products through our sales reps like me or my colleagues, but you can also order profiles through the web shop. You can order 24/7. You will see the current stock situation. You will see your prices, your personal discount rates. But before you get web enabled, please get in contact with me to negotiate on prices. You will see the order history, and you can save your own favorites. In the future, there will be also an opportunity to cut the profiles to size, and you can drill holes, for instance. You can save your own delivery address in the system so that you don't have to type them in every time you place an order. We offer also FRP deckings, claddings, and cover for service and pedestrian applications, for instance. We hold them in 6 and 13 meter lengths on stock. They are available including anti-skid surfacing and without anti-skid surfacing. We offer 2 different colors on the anti-skid system on the web. We have different fitting solutions to steel substructure, wood, and FRP substructures. We offer brochures which you can download from the web page, and also for the bridge deckings, load tables. We do offer a road bridge deck as well. I will tell you a little bit more about later on. We do hold on stock also molded gratings. They are produced in a different process. All fasteners for profiles, decking system, or molded gratings are made from stainless steel. And now I'm coming to the application areas. On the right-hand side, you see a new build structure. Consists out of 3 ramps made from full composite structures. The main span is a hybrid structure, a steel truss bridge with an FRP decking on top. On the left-hand side, you can see a refurbishment scheme. This bridge was built in '97, and after 15 years, the timber bulks and the large decking has been replaced by FRP beams and our HD plank decking, including anti-skid system. You can use our FRP products for road bridges, pedestrian and equestrian bridges, temporary bridges, ramps, extension, cladding, and railings. You can design full FRP structures in different ways using pultruded profiles, such as beam bridges. The maximum span on a beam bridge is about 9.2 meters. You can strengthen single beams with our carbon strips, which gives you about another meter of span. You can build bridges, FRP bridges structurally, such as truss bridges, for instance. Maximum span 21 meters if you have a width of 1.5 meter. If you increase the width of the bridge, then the span drops down accordingly. We build full FRP bridges as arc bridges up to 45 meters, and from 45 meters, cable stayed bridges. As just mentioned, we do FRP bridges, but you can use FRP profiles and decking system for hybrid applications as well. We have supplied the HD plank, our pedestrian bridge plank, for more than 3,000 bridges. I like to give you an indication on costs. The HD plank, including anti-skid system, including fittings, it's about 140 to 180 euros a square meter. The UD300 plank, load application, I'll tell you later on, including anti-skid and fittings, is about 350 to 400 euros a square meter. For both profiles, the installation cost is about 25 to 50 euros a square meter. Hybrid structures are, for instance, steel with FRP, concrete, timber, or even aluminum. There are different industrial application areas, such as railway crossings, sewage plants, industrial application, coastal application, public, caves, jetties, and swimming pools. These are full composite structure, which I'm showing here. Offshore industry, mountains, highway crossings, service walkways, tri bridges, and gantries. We never supplied material for a gantry. Feel free to contact me. I'm looking forward to have a gantry made from FRP. On the upper right-hand side, you see a special project. It's called the Pontracino Bridge. It's located in the mountains in Switzerland. It's built in '97, comprising 2 spans. One span is 12.5 meters. The left-hand side is bonded and the right-hand side is boarded together. It's been lifted twice a year because in the springtime the flood comes. It needs to get, there will be placed next to the river and being installed afterwards again. On the right-hand side you have a hotel, and on the left-hand side you have the ski reservoir. The altitude is over 2,000 meters and no paint has been used on that bridge. There is a report on the durability of the bridge made by the University in Zurich, and you can have the report. I can share it with you. Please get in contact with me. The advantages of using FRP profiles in the bridge industry. First of all, I like to go to tell you about the product itself. For all our structural profiles, we are using a fire retardant isophthalic polyester. It has high mechanical properties, a high chemical resistant. It is normal flammable, self-distinguished, and has no flame spread. We reach fire class according to BS 476 part 7. We reach class 2. It has a high strength and low weight ratio, as I told you in the beginning. Long lifetime. It has little or no maintenance over lifetime. It is a very environmentally friendly material, has good electrical insulating properties. It has no theft value, good thermal insulating properties. It is easy to machine and easy to handle. Coming to the practical side of life, to tell you the advantages on real life structures. Scottish Water requested bridges which are lightweight and also durable, because there were no opportunity to have access to the location of the bridge because it was a remote area. So both structures, service bridges you see here, have a span of 13.5 and 12 meters in different width. Both frames weighed below 900 kilograms. So there was the opportunity to flew them in by a helicopter. Actually, I wanted to tell you a little story about the helicopter pilot. He actually did the camera for this James Bond movie. It was quite interesting to hear from Simon Newby from CTS Bridges, who did a lot of photographs and also was flying with a helicopter as well. This shows you the lightweight of the structure itself. I'm now talking about a bridge called Church Road Bridge. It's located near Bristol in Frampton Cotterell. It shows you the low craneage, less possession, lighter foundation. You could reuse existing foundation and abutments, and it's built off-site or in the factory. It's a road bridge. Now I show you a movie, and I will tell you a little about, through that movie, a few sentences about the bridge project itself. Lee Canning from Jacobs, Manchester, he did the detail design. James Henderson from Atkins in Swansea, he did the category 3 check on that project. The dimension of the bridge is 9 meters in width, in span, and 12.5 meters in width. It can carry load up to 45 tons, and the bridge consists of main FRP beams, square tube profile 200 by 210 millimeter wall thickness, strengthened by carbon strips. The main deck itself, it's the FBD 600 profile, former called acid profile. On top of the FBD 600 profile, there were flat strips bonded 500 by 10 millimeter as a sacrificial layer to protect the FBD 600 decking over time. The bridge has been prefabricated in 3 parts by CTS bridges, and these parts have been shipped to a location near the construction site. 3 parts have then been assembled and transported down the road to its final location. The bridge lifted in just within a few hours only. The balustrades has been made from traditional brickwork. The FBD 600 campers are filled with polymer concrete, and the brickwork is anchored to the FRP structure. Between asphalt and FRP, you can put a bitumen emulsion in between to connect both layers with each other. The square meter price of this bridge was about, was about 1,500 euros, and 60,000 euros was the installation cost. And the installation cost was coupled with other costs such as service diversion and temporary bridges and the temporary bridge. Now I'm talking about the durability of FRP profiles. And we are, together with the customer, we have tested FRP profiles from a cooling tower, which was 20 years. Sorry? Sorry
to interrupt, but it's stalled. The film has stalled, and it hasn't changed page if you've changed since the film.
Okay, I go back and start again.
Okay.
Do you see the presentation now?
Yes.
Okay, sorry. Please bear with me. It's the first time talking to a computer, and sometimes I'm struggling with the pages here, but please bear with me. So this cooling tower was more than 20 years of operation, and the profiles were exposed to elevated temperatures, permanent humidity, and processed to water. Consists of chemical content because the water being reused all the time. And they carried out a test of a profile. They did some tests on tension in transversion direction, compression in pultrusion direction, and did some microscopy investigation as well. The results are showing very low degradation of the properties. The degradation is within the range of expectation. I should further mention that these degradations are captured by partial and safety factors that are recommended by Fiberline 20 years ago. I tell you about our Calding Bridge. The bridge is the oldest European pedestrian bridge, which was built in '97. It's nearly 25 years in service and runs over a railway track line between Calding and Copenhagen. It's an electrified railway line. The bridge is located next to the seaside. We have also a saltwater application here. The dimension of the bridge is 3.2 meter in width and 40 meter in span. The whole bridge weighs 12 tons only. A comparable timber bridge would weigh 30 tons. It's a full FRP structure. Only metal bolts have been used. Also, the cables from this cable stayed bridge are made from FRP. There's no maintenance at all, only cleaning of the graffiti, for instance. I haven't mentioned that until now, and also not when I talk about the advantages of the profiles. But these railway crossings, they have another advantage, which hasn't And it has a positive effect in terms of safetiness due to its high strength and low weight ratio. If you imagine an intermediate pillar or supports being destroyed through a train accident, for instance, the bridge itself will not fully collapse and remain its position, but will sag without collapsing. 3 load-carrying members has been investigated after 20 years of service and compared with its mechanical properties in the beginning. And what they found out is that the mechanical properties decreases by 4 to 6%. But the stiffness is increasing. And it's because FRP never cures out over lifetime. And this has a positive effect on its bridge frequency, because we are talking about a lightweight structure. Another practical advantage, we offer a standard design beam bridge. And it was a first-time touch of a company in the Netherlands called DEC Products. This is a project of the city of Venlo, near the German border. And on this one, I can just tell you that it's easy to machine and easy to handle, even if you use FRP the first time. As you can see, the beams have been delivered. They cut the holes. It's a family-owned company, so everybody was working with the material the first time. And they did a very good job. Easy to assemble and also easy to install. Please get in contact with me. I can share the contact details of Harald, who is the managing director of this company. I wanted also to mention that behind every post, you can see the railing in the middle of the picture, and the right-hand side also in the middle, there are cross beams. You have to place transversal beams on each post because FRP beams are restricted to torsion. I'm talking a little bit about later on as well about the environmental impact of FRP to the nature. It has a less carbon, but I will show you a small movie, and for that I need to go out so that you will see the sound. Hear the sound, sorry.
Sustainable. Here at Fiberline, we do our utmost to use our resources efficiently and to protect the environment as best we can. At the same time, we also give our customers the option to create sustainable growth by using us as a part of their value chain. Our products are manufactured in a continuous process known as pultrusion, a closed process which effectively limits the evaporation of volatile substances and keeps energy consumption low. As a natural consequence of the unique durability, you will have a very limited need for additional paint, chemicals or machinery to maintain the profiles throughout their long lifetime. When the materials are no longer needed, they can be efficiently reused, for example, in cement production. Fiberline, create more with less.
So the next practical advantage is the anti-skid system surface we supply our product with and the high slip resistant. FRP has no own moisture as wood, therefore it's non-slippery. We are using a polyurethane based anti-skid system in 3 different slip resistant classes. We can apply slotted holes for drainage, and we are able to CNC the planks to any shape you like. They're always 500 in width, the plank, and it also follows the natural curvature of the bridge if you have a hybrid structure with curved beams, for instance. Christopher Lewis from Capital Simons said the timber footbridge deck was very slippery and dangerous, but using fiberline deck has removed this hazard and also looks good. No earth bonding required. Ilexis, one of our customers in the UK, there is no need of any earth bonding due to good electrical insulating properties. These solutions are in keeping with Network Rail CP6 resilience targets by offering a lightweight, robust, earth-free and hand-portable solution. This system were installed and platform erected in under 2 days on the upper right side of the picture. They delivered a lot of platform systems to Network Rail. Actually, Frp has also very good impact resistant. And I want to mention that because many people think it's like brittle, but it's not. This was a car accident over with an Frp ramp in the Netherlands. This ramp has been built by a Hazelnut broken. And what you can see on the upper left-hand side, the picture, that the damage stays locally and it's not spreading all over the beam. Local damages can be repaired. For this, we came up with a fabrication and repair manual, which you can download from our webpage. Please do so. I'm talking about load applications. Our HD plank decking is according to Eurocode 9 loading, and it can cope with 5 kilonewton per square meter, a patch load with 10 kilonewton, a patch load area of 100 by 100. And if you take a deflection L over 200 into consideration, the maximum single span is 1.3 meter. If you have a 2-span or double span, it's 1.3 meter. It can take service car loads up to 3.5 ton. But please be aware, according to Eurocode, without taking into account an exceptional load of 12 tons, the bridge needs to be secured with bollards. The UD300 plank is fully compliant to Eurocode 9. It can covers additionally to the pedestrian loading 5 kilonewton, 10 kilonewton, up to 12 ton load. The maximum span between the girders must be reduced to 0.5 meters if you put a 12-ton car on top. This has to do with the shear capacity of the profile in combination with the bending. If you have a normal pedestrian loading on top, excluding this 12-ton car, then the maximum single span L divided by 200 deflection criteria is 3 meter, and if you have a 2-span, it's 4 meter. Many of the steel road bridges consisting of a timber decking on top. Clients always look for a lightweight and durable solution, which is Frp in this case. I'm coming now to the load application of the FBD 600 road bridge deck. The maximum load is 60 tons. You can build full Frp bridges up to 12.5 meters. If you have a hybrid structure, the distance between the beams are maximum 1.3 meter. This profile has been developed between 1992 to 2002 and was founded by the EU. The FBD 600 plank was formerly called Asset Decking, which means Advanced Structural System for Tomorrow's Infrastructure. The project has had a budget of 4.2 million euros. This bridge deck has been fully tested. For example, all mechanical tests have been obtained and dynamic test has been carried out with 10 million cycles on a 40-ton patch loading. Dynamic tests are still ongoing at the Bristol University. There were many parties involved. we as Fiberline Composites who developed the profile, Mouchel, now Jacobs, then test centers in Spain, universities in Sweden, and then we found a project called Oxfordshire County Council project. The contractor was Skanska, and this was the first FRP road bridge using the FBD 600 profiles in the UK. For more information, please get in contact with me. I'm now talking about the environmental impact in comparison to traditional materials. There's a report available from the Netherlands Rijkswaterstaat, and you can download this report also from our webpage. There were 5 different bridges material-wise compared with each other. We are talking about a steel bridge, a stainless steel bridge, an aluminum bridge, and a concrete bridge in comparison with an FRP bridge. And a comparable FRP bridge has a total energy consumption of 12 gigajoule, which is only 45% of the next lowest. The stainless steel bridge has a total energy consumption that is 2.75 times higher. The reduced environmental impact is a key characteristic which clients and designers should be aware of. The report can be downloaded from our webpage. Looking now a little bit deeper into the loads on air, for instance, then you will recognize that gray concrete and blue aluminum has a higher impact on the air pollution than steel and FRP. But looking at the water pollution, you will see that even steel, concrete and aluminum has a much higher water pollution than FRP. Now, cost comparison. I would like to go in detail more through this table. You can get this table from me as well. I compared 4 different bridges material-wise. I'm talking about a steel bridge with enlarged decking on top and hot dip galvanized steel railings. I compared a timber bridge with a large decking and an oak railing, a full aluminum bridge with an FRP bridge. We are talking about initial costs, ex works, fabrication, assembly, coating, bearings, detail design, etc. We compared 2 spans, a 9-meter span and a 15-meter span. The width of the bridge, 2 meters. You can see that the initial costs are higher than aluminum and FRP, for instance, a traditional steel and timber bridge. Now, taking into account a lifetime of 70 years, you have to give a certain percentage each year on top of the initial cost to get the whole life cost over 20 years. And the results, excluding interest rates, that's important to say, you will find out that the beam bridge, an FRP beam bridge, is less expensive than all other materials. The truss bridge is a little bit more expensive than an aluminum bridge. But when considering environmental impact, the FRP solution should be the right solution to go for. I'm now talking a little bit about the design guidance. And as you all know, there is no Eurocode available at the moment. In the 90s, they came up with the Euro norm called EN 13706. They are part 1. They tell you about the designation. Part 2, it tells you about the test methods and general requirements. And in the third part, they tell you about the specific requirements, such as mechanical properties. There are 2 grades, E23 and E17. It's very important to say that these are minimum values. We at Fiberline, we have the European Technical Assessment, where higher mechanical characteristic properties are stated. In conjunction with the CE certification and quality assurance system, the client can rely on all Fiberline mechanical properties by 100%. We get audited by the EOTA member twice a year. We have a material traceability system with production number. For instance, we check machine settings, velocity, temperature on more than 3 points in the tooling. Compliance of specification, such as dimension, creep, elasticity modules. We have a raw material tracking system, batch number of suppliers. All our profiles, they have a designation with a permission and license number, profile dimension, matrix type, and item number, and the fire class according to the German code. It took 10 years and 2 PhDs on mechanical connections to get the German building permit released. Our material has been tested extensively. This is a 38-pager, and it gives you a good way when designing FRP structures of any kind. Now, there's no need of any category 3 check or any additional testing to prove material properties, which saves time and money. This building permit is valid for Fiberline profiles only. It gives you design guidance through the serviceability limit state, ultimate limit state, and it gives you safety factors for temperature, medium, and time. It tells you also about the structural design guidance, how to connect profiles with each other. What do I need to be aware of when mounting square tube profiles to FRP beams or steel beams or even wooden timber barks? Please go through it. It's very easy to use. In 2022, we all hope for there will be the new Eurocode coming out. But there is a former prospect for new guidance in the design of FRP available for free for download. And it's more than 300 pages. And there are all kinds of Gfrp processes covered, not only pultruded profile, also molded structures and sandwich elements, for instance. This prospect and the protrusion part is very similar to the German building of the content of the German building permit. I'm talking about connection methods. Bolt connection can be designed in accordance with the German building permit. We achieve high pin bearing capacity in comparison to the EN 13706 stated. Minimum values are still require more bolts in a connection than other materials to transfer the forces. Therefore, you have in these the connection points more bolts. But there you can use an adhesive connection as well by using a 2-component epoxy or adhesive. This requires surface preparation. The right moisture and temperature is required and need documentation. Generally, you can say after 24 hours, it's reached about 70% of its strength, and after 7 days, 100%. It will never fail in the adhesive itself. It will rather delaminate the profile, and therefore you can put a calculation behind that. Please find more information in our Fiberline and fabrication and repair manual, which can be downloaded from our webpage. A combination of mechanical and adhesive fastening is the most efficient way to go for. It gives a good rigidity and robustness within the structure. I'm talking about painting an anti-skid system. And painting has nothing to do, or coating has nothing to do to protect the material. It's rather used for aesthetical reasons. Even though the color fades out within time, or you have scratches on the bridge in the paint, you don't need to go there and maintain it. But every engineers know if you coat profiles, doesn't matter which kind of material, it will also extend its lifetime. You have to prepare the surface with a Scotch-Brite, for instance. You clean it and you go directly on top with the paint. We recommend the first layer 30 microns in the white color and the raw color with 30 microns on top. We recommend a few painting systems, which we can of course forward you the suppliers for. Anti-skid system, it's a polyester material and you can apply a numerous of anti-skid systems made from epoxy, polyurethane, MMA, bitumen emulsion and asphalt. When we talk about pedestrian bridges, you can directly go on top of the main carrying bridge deck. But when we talk about road bridges, then please use a sacrificial layer between the load carrying decking and the asphalt or epoxy or polyurethane anti-skid system. This is to protect the load carrying Frp profiles underneath. Imagine after 20 years, the asphalt will be replaced and this big grinding machine comes. So this is to protect the load carrying members from underneath. Now I went through my presentation and I wanted to thank you very much for listening. Today I would love to give you an offer. Please bear with us, but you get them for free of charge today, our sample boxes. And we have not a lot on stock at the moment. So maybe it takes a few weeks in receiving it. But it was very strange for me. It was the first time talking to a computer, as I said. And hopefully you have enjoyed my presentation. And please get in contact with me. I'm looking forward to hear from you. At the end, I'd like to answer a few questions. And thank you very much for listening.
Questions that's come in.
Hello.
We have a guy here that says, "Hi Christian, I would like to ask 3 questions.
3.
Please compare to structural grade steel. Is Gfrp cheaper or more economical?"
Yes, when you see the material itself and compared to a steel beam, then it's more expensive. Even though it's 4 times lighter than steel. But when you see the handling, the fabrication, installation, and so on, you will, and also the durability within lifetime, you will have the money in the pocket. But initial cost will be about 10 to 20% more expensive than using a traditional material.
Does the color affect the structural integrity?
We are using a fire retardant isopolyester and we don't coat them. It's a natural color of the profile itself. If you use, if you want to give them a natural color in the polyester itself, then you will need to use chalk pigments in there, but this will decrease mechanical properties. Therefore, we at Fiberline, we recommend to paint the profiles with a polyurethane paint.
Does the material require regular treatment and maintenance after installation?
Yes, when you bolt the structure together, after 48 hours, you need to re-strengthening the bolts. We suggest in the German building permit, talk forces for the bolts itself. When you have a coating on top and it fades, as I during my presentation mentioned, even though it fades and you have scratches, you don't need to go there. Within time, if you don't paint them, then it will get rough on the surface. We are using an 0.4 millimeter polyester veil, which protects the profile from degradation. But the first layer will corrode through abrasion, UV light, changing a little bit in color, but it will not affect the mechanical properties of the profile over lifetime. But of course, we all getting older, you know, and I told you that that mechanic properties will go down about 6% with 25 years. But I can also tell you that when you design a bridge for 70 years according to Eurocode, it will last longer.
We have a question from a guy called Patrick Savage, I think. He says, "Hi Christian, good to see you again. Have you undertaken any studies to compare the relative embodied energy required for the production and use of FRP for structural purposes compared to steelwork, timber and concrete?"
Yes, this is the only report we have with the energy embedded impact. But we are using, for instance, I don't know if I'm answering the question very precise, but we are using the energy from the wind industry, for instance, where we deliver our profiles to. So we, in order to produce our profiles, then of course we get the raw material and so on. We are a very green company, but we haven't. I don't know if there's anything available on the market. I need to research. I need to ask my product manager. He will come up with a solution to compare what it takes to make the glass, the polyester in comparison to steel and timber, of course. But I'll come back to you, Patrick. Thank you for your nice question.
Another one, Karslandra, I think it is. It says, "Hi Christian. It would be interesting to know the details on the cost comparison studies against the conventional bridge materials."
Yes, this is what I did in my price comparison over 70 years lifetime. I think that answered that question, don't you think?
Okay, we'll take the next one. Kai is asking, "Hi Christian, I heard the modules of Gfrp profiles can be increased by attaching carbon strips. May I ask the extent of the increase? Is there harmful effect on bolt holding ability?"
I didn't get this question straight away. So you can strengthen our profiles with carbon strips to increase span, but you are using adhesive to bond these carbon strips to our FRP beams, but we don't bolt them. CFRP profiles, they have fibers in longitudinal direction only.
And Matt is asking, "In your bridge deck profiles, how do you inspect and control defects that are not visible on the surface, for example, waviness and misalignment on the fiber mats, and yes, that may vary between different pultrusion batches?"
What we do at Fiberline, we have a quality control system. Every 200 meters, we do a bending test for the e-modulus. Then we test our profiles very carefully. We see dry fibers immediately, and we are not selling them to the market. We put them to the scrap. And I'm getting also, maybe I should mention that as well, I'm getting also question, how to inspect bridges after 5 years, and what can I see if there's any damages, and how do I do and check the bridges? And in the German building permit, it's stated that you have to use how do you call it, inspector who is qualified to do that. But I can only say that if you just make a bending test, for instance, if you have a bridge, you put a car on top and then you measure the bending in the beginning and then after 5 years, and then you see the difference. But you have to look into more detail on the repair and fabrication manual, for instance. We mentioned something there as well. But there's also some in the former Eurocode. There's also a maintenance chapter which you can have a look at it.
Okay, I think we've got time for 2 or 3 more questions before we have to close it down. Somebody's asking, is it possible to buy all your products online?
Yes, you can buy them online in our web shop. And please get in contact with me. We will web enable you, and then you can order them straight away from the web shop. You will immediately get transport costs, and it works very well. And we had very good success. We have many customers in the web shop, so you will be surprised.
A person is asking, please talk about the fire resistance and compared with standard material.
Yes, fire. It's a it's normal flammable, self-distinguished, and has no flame spread. If you put a fire underneath an FRP beam, it will start burning. But it will not spread the flame. If you take the fire apart, then it will self-distinguish. In comparison to wood, for instance, wood is a good fire protection material because the core remain. This is not with FRP, it will collapse. It's the same as steel. What you can do to improve fire protection, you can coat them with a special coat. We can give you the context of this coating supplier, which has also a brochure and explain more about its detail. We can reach with that coating class 1 according to BS 476. Okay,
last question, and I think people can always get in contact with you, can't they, and email you if they have any more questions.
Yeah.
We have one here that's come in. Is the material suitable in a marine environment, especially if there is direct spray or even water from waves falling on the surface?
Yes, it is. It's very salt resistant. And yeah, this is what I can say. We have a surface way of protecting. And when you see boats and ships, of course, they have a coating on top as well of their FRP. But we had never any claims on using FRP in the marina environment.
Okay.
Yeah. So thank you very much for listening. And if I haven't answered the question in detail, which you would love to have, please get in contact with me and we will find out the right answer for you.
Yeah, and the details about you can be found on our website.
Exactly, phone number, email address, and so on. Thank you for listening.